Okay, last trig examples. Evaluate the following limit. So always substitution first. And so that's going to be 1 minus 1 over 0, 0 over 0, indeterminate. And remember, if you tell me that 0 over 0 as a limit gives you anything immediate, that it gives you 1 or 0 or it does not exist, all points go away. So this one, I am still going to try to use that sine x over x limit, but this takes a special little trick, which I wouldn't expect you to know, but I'm showing this more almost from a cultural standpoint than anything. I'm going to multiply numerator and denominator by the conjugate of the numerator. Now remember, when you multiply conjugates, same terms, different signs, you always get first term squared minus second term squared. So when I multiply these guys together, I'm going to get 1 minus cosine squared x over x times 1 plus cosine x. Now there's some obvious trigonometry here. You've got to know those basic Pythagorean identities. And one of the most basic Pythagorean identities, 1 minus cosine squared x is sine squared x. Then one more trick. And again, I know to take these tricks, because I've been doing this a really long time, I'm going to split that up. And notice I have created that special limit. And so very technically, I can split these guys up into two separate limits. This first one is going to be 1. Memorize it. And this is 1 times, and then this next one I can do by substitution. And so I have 1 times 0 over 1 plus 1, 1 times 0, or 0. And so that limit is 0. In general, the limit as x goes to 0 of 1 minus cosine mx over mx is 0. Again, we like to see that argument, that angle, match the denominator. Now, there is not a reciprocal one. We can't flip this one over because there is no reciprocal of 0. The reciprocal of 0 is undefined, so you only just have this one limit. And this limit's going to creep up every once in a while, so just be familiar with it. And this concludes the lecture from sections 2.2.2.4. You should be able to do the problems in the homework assignment from 2.2.2.4. So we will conclude this lecture.